Everyone, thanks a lot for coming. I see some familiar and some also not familiar faces, so it's a good mix of people, and I look forward to getting to know those that I don't know yet. So let me welcome you to this now third Industry Engagement Day of the CCIMI. We are very pleased that so many of you could join us today. And for those of you for whom the Institute is new, the meeting today is organized by the Cantab Capital Institute for the Mathematics of Information with support from the Turing Gateway to Mathematics. And to tell you a little bit about this institute, the institute is based in the Faculty of Mathematics here in Cambridge, which is made up of two departments, DMTP, the Department of Applied Mathematics and Theoretical Physics, and DIPAMS, the Department of Pure Mathematics and Mathematical Statistics. And it's really a genuine effort bringing together a diverse range of mathematicians from pure mathematics like number theory to statistics, applied and computational analysis, fluid dynamics, mathematical biology, theoretical physics. And we want to bring all these mathematical areas together to collaborate on the pressing needs of the data revolution, so developing new mathematical theory and methodology for extracting information from data. The Institute has been founded about 2 years ago out of a generous donation from Cantab Capital Partners, who are a local hedge fund here in Cambridge. Matt Killeya, one of the CEOs of Cantab Capital Partners, is standing next to me and will shortly address also a few words to you. So let me give you a bit of an update on what the Institute is up to. After 2 years of launching our work, we are now forming one of the main substantial hubs for foundational research in data science, with a faculty of more than 30 mathematicians, ranging from pure analysts to statisticians and numerical optimizers. 2 special Cantab lecturers, Hamza Fafsi, who is an optimizer, and Quentin Berthet, who is a statistician, and both of them will speak about their research later on today. We have 2 cohorts of PhD students, 3 Cantab research fellows, postdoctoral research fellows, and a rich teaching and research program that is also outward-facing with a distinguished visitor program for hosting internationally renowned researchers. So we are all very excited about where we are today and look forward to what is coming. And so the question is, of course, with all these data science, big data institute popping up in the UK, but also internationally around the world, what is so special about the Cantab Capital Institute? And I think the answer to this is very short. It is based in one of the most world-leading mathematics faculties in the world. And like physics was at the heart of the Industrial Revolution in the last century, there are many reasons to believe that mathematics is at the heart of the ongoing information revolution. And therefore, what could be better than to bring together a diverse group of mathematicians to help and lead this revolution? So the talks and posters we will see today will showcase the research that is being carried out in the Institute, and they will present also an opportunity to hear in detail some about the current project collaborations, other industry challenges, and explore new potential collaborations. The lineup of speakers shows the important role that foundational mathematical research plays in various aspects related to large-scale and high-dimensional data analysis, to heterogeneous data analysis. So in the morning, we will start with talks from one of our CCIMI lecturers, Hamza Fafsi, as well as a delegate from Google DeepMind, who will discuss the mathematical challenges in computing solutions to highly nonlinear data analysis models. The second part of the morning will be on some of the opportunities that industrial research provides, with very interesting problems presented by 2 of our CCIMI industrial partners, MPL on new measurement modalities, and by Unilever on how data analysis can help to make better ice cream. We will then have lunch with a poster session where you will have the chance to look at the research that the PhD students and the postdocs in the Institute are working on. And this is then followed by, I think, a very intense but also exciting afternoon with presentations of our partner and co-founder, Cantab Capital Partners, on high-dimensional data analysis of option prices. The second CCMI lecturer, Quentin Berthet, who will speak about statistical and computational solutions for sequential decision-making, and a presentation by Tesco, where the role of decision-making in a complex scenario such as trade is discussed. And then we will finish the day with a panel discussion and a drinks reception. So I believe we can look forward to what promises to be an interesting day, and I would like to thank you all for joining us for this. And now I'll hand over to Matt Killeya, who will open the meeting. And we should swap.
All right, hello everyone. I'm getting quite used to sort of standing up at the Institute now and welcoming people to events, which is actually very nice for me. Lots of familiar faces here today, so great to see you all again, and some new people as well. So looking forward to getting to know you guys as the day goes on. Let's see, I've got a few. So I should apologise for writing my notes on this tatty envelope. I've written them on the front, not the back, so it's not a cliche, at least. So first of all, welcome. I just want to take a few moments to say why today is important. So as Carola pointed out, we're sort of living in the data age now. Things are changing pretty quickly, and there's sort of three key factors there. First of all, it's data. We're just collecting a lot more of it than ever before in our history. We've sort of collected something like 90% of all data that we've written down in the last few years. That's a pretty staggering statistic. So there's a lot more data. Secondly, there's a lot more computing than ever before. So Moore's law, which dates back a few decades, is sort of continuing to hold true in the sense of that doubling of computer process, essentially doubling of computer processing speeds. Roughly speaking, it's held true much longer than I think Moore himself envisaged. So much faster, more powerful computers. And then thirdly, obviously smarter mathematics, which is obviously the speciality of people here. So our ability to take all that data and extract more information from it than we could do previously. So all these three things working together are actually creating that data age or that information age. So that's a really interesting thing. It's something which obviously gives challenges and also opportunities. We at Cantab, a systematic hedge fund or investment firm, we've been building algorithms to manage investors' money for the last 10 years. So autonomous algorithms which sit on a computer, they are effectively we like to call it a money machine sometimes, so it's autonomous algorithms which manage money. So this has been a very challenging and interesting area of research for us, and we have a big research group, and you'll hear from one of our guys, Sam, later today on some of the research we're doing. But over 10 years, in recent times, we've seen big changes, and in particular, interesting new data sources are knocking on our door every single day, and with them, new challenges. So in particular, we're looking at things like news data. Can we harvest all the different news information out there to learn about financial assets and make predictions about moves in those assets to improve the investment process? Weather data, big databases of global weather coverage, which relate clearly to things like commodity prices and agricultural contracts. Some of you would have heard Chris, one of our senior researchers, talk about the work that we're doing there in a previous event. And then also shipping data, which I think Chris has also spoken about. So, high granularity shipping data around the world, which again relates to movements in commodity prices, things that we can trade, financial instruments that we can trade, and better manage money for our investors. So we're very lucky, essentially. We've got very interesting data, very interesting problems to work on, and that's great as far as we're concerned. And that sort of takes me, I think, to the key point of today. So, you know, there's lots of us working on very interesting and challenging problems, and the Institute, as Carola said, is a very diverse collection of people working on quite different applications and different problems, but all of us working on challenging research questions. And I think the key point is that actually when those things often feel quite different, often they can be quite related, more related than we might anticipate. So, you know, just to take a couple of quick examples, you know, the heat equation, driven by principles from the first law of thermodynamics, is something that also revolutionized the financial industry and gave rise to options pricing, left a couple of guys, Merton and Scholes, with Nobel laureates for the work they did there, and opened up a lot of liquidity in financial markets, which filtered down to have many benefits for ordinary people. And you know, who would have thought that you know, something that started as a heat equation in a you know, driven by the principles of energy conservation and the first law of thermodynamics, would make its way through to be useful in the pricing of financial instruments. A total surprise, actually. Another great example, I mean, one that we've been really interested in recently, is all the work being done here at the Institute on image processing, image reconstruction, a really interesting area. Can you take 2D images and reconstruct a 3D surface? Very powerful potential applications in medicine, medical imaging, and other areas too. So we look at that with our financial perspective and see some of the mathematics which is used there, and this sort of idea of total variation and these sort of absolute value terms which are used at the heart of some of that analysis. The same equations, the same mathematics directly relate to work that we do in portfolio optimization and construction, in particular related to transaction costs, when we're trying to model the impact of transaction costs, when the information changes and our models want to change positions in the financial markets. That's actually a very challenging problem to try and optimally handle that phenomenon. And so suddenly there's a relationship between somebody working on image processing and medical applications and our own application in finance. So lucky for us, we found some other smart people working on a very hard problem, and maybe they could help us, and maybe we could help them too. And so that's really my key point today. When you come to a day when there's lots of different people talking on quite a diverse range of topics, that's potentially very useful for you, and that's what I would urge you to do, is to try and make that useful for you today, to look for those connections. It can be quite isolating being a researcher sometimes, whether you're a student or whether you're further on in your career. Sitting in a room by yourself trying to answer difficult questions can be tough. So, you know, if you find that community is actually a bit larger than you thought, there's someone else working on a very related or the same problem, also bringing a different perspective, that's actually a very powerful thing. And so hopefully that will happen to you today in some way or another. And I would, as I said, urge you to look for those connections and also try and help people where you can as well. If you see connections, then you can point them out to people to help them. And if we do a little bit of that today, I think that'll be a great outcome for this very interesting day. All right, I think that's all I have to say. So thank you very much and enjoy the day. Cheers.